Good morning, kindergarten and first grade kipsters. This is Mr. Jennings, and this is your science class. I'm glad that you guys checked in again. Make sure that you are being safe during our shelter in place, but also make sure that you're still exercising with Miss Hegwood and Mr. Flores, getting all of your exercise out, getting your energy up, getting your muscles up. So we've been learning about the spinning Earth and learning how the sun appears to be moving across the sky. Today, we're going to use evidence and investigations to evaluate different models of the sun moving across the sky. We also need to remember that our big question is, what can we see in the sky at different times? So we're still going to be focused on that big question. Before we push on, we're going to look at our vocabulary words. So first off, we're going to start off with our big question is, what can we see in the sky at different times? I want you to take a second and think of some things that we can see in the sky at different times. Cool. I know some of the things that you guys may have came up with, like we might see the sun in the sky, maybe the moon in the sky, some stars in the sky. I know we read a book and we seen like an airplane, a bat in the sky, clouds in the sky. We might see rain in the sky. There's different things that you can see in the sky at different times. We're learning about these things as we move on. We're going to look at our vocabulary words. So we're going to preview some of our vocabulary words. Please say them with me. Earth. Earth is our planet. Earth is good. Earth is our planet. Horizon. Horizon. Horizon is where the ground and sky meet. So it looks like the either the sun is going into the ground or coming out of the ground. And the sunset when it's going in, sunrise when it's coming out. Model. Everybody say model. Models shows how something works. Models Good. Model shows how something works. We're going to be focused on models today because we're going to be seeing a model of the way the sun can create shadows and how a long time ago the shadows helped people figure out what time it was. So they always didn't have watches or clocks. They used shadows and the sun to figure out what time it is. Pattern. Pattern. Everybody say pattern. 1 2 1 2 1 2. Pattern is something that repeats. Pattern is something that cool. Rotate. Rotate means to spin. Rotate means to spin. Rotate means to spin. Very good. Season. Everybody say season. Fall, winter, spring, summer. Fall, winter, spring, summer. Good job, you guys. Cycle. Cycle are repeating events. Cycles are repeating events. Cycles are very good. Temperature. Temperature is how hot or cold. Everybody say temperature. How hot or cold. Everybody say how hot or cold. Arc. Arc is a curve. Arc is a very good. Arc is a curve. So a curve is like a rainbow in the sky. Think about like when you see seen a rainbow on TV and you seen like the rainbow go up and it's like a curve and it goes down. That's how the sun moves across the sky. So today we're going to be watching a video. We've seen this video before, and in this video we're going to zoom in more, seeing how the sun looks like it's moving across the sky, and also how the shadows or how the sun makes the shadow move. So here's our video here. We're going to watch this video and see how the sun is moving in an arc-like way in the sky, and how shadows are moving based on where the sun is in the sky. So this is just like the unit we had about light and sound. So when something blocks the light, it creates a shadow. If you said shadow, great job. When something is blocking the light, it creates a shadow. And so when we have things blocking the sun from getting to the ground or to the surface, it creates a shadow. And depending on where the move is, where the sun is, the shadow can move. So you might see your shadow longer or shorter, or your shadow is in front of you, or in back of you, or on the side of you, or the right side or the left side. This is because the sun is in different places. So even though you're standing in one place, you still might see your shadow in different places based on the time.
noticed, maybe on a nice summer evening and you're running around outside, that your shadow looks super long, but then, at other times of the day, it's really short? What's up with that? Does your shadow have a mind of its own, like Peter Pan's? Nope. I mean, I hope not. That would be strange. To understand how shadows move over time, let's talk about what a shadow is exactly. Say you're standing outside in the sun and you spot your body's shadow. Your body is solid. That means it can block sunlight. Since sunlight can't pass through your body, it makes a dark area behind it, opposite from the direction the sun is coming from. This dark part where the sunlight can't reach is your shadow. So why doesn't this dark patch stay in the same spot throughout the day? Well, for one thing, you move, so your shadow moves with you. But let's pretend you stand in the same spot all day long. No, wait, that sounds super boring. Just picture something that doesn't move around, like a tree or a building. Its shadow would still move throughout the day. That's because the shadow is made by the light of the sun, and the sun is constantly moving in the sky. Well, you know it's not really the sun that's moving. You should definitely check out our video about how the Earth moves or rotates on its axis, making the sun appear to move across the sky. Even though it constantly seems to be changing where it is in the sky, some people know exactly where the sun's gonna be at certain points during the day. In fact, ancient civilizations thousands of years ago used the sun like a giant clock. They could tell what time it was based on the sun's position in the sky. How'd they figure that out? Because the sun follows a certain pattern every day. These civilizations saw the sun rising in the east and setting in the west, day after day. Soon they were able to guess what time it was based on where the sun was on its path from east to west. Cool, huh? And since the movement of the sun follows patterns during the day, so does the movement of shadows. Any idea what those shadow patterns might look like? Let's find out. We'll follow the sun for a day and see how it changes the shadow of a specific object. Then we can chart the length and the direction of the shadow from morning to evening to see which patterns we can spot. First, let's pick an object that stands still, not running around all crazy. Like, how about a lamppost? Say one that's about 4 meters tall. Now let's start early in the morning, 7 a.m. Sun, show us what you got. The lamppost has a pretty long shadow this early in the morning, and it looks like it's extending to the west. What happens to the shadow if we fast forward to 9 a.m.? Interesting. The shadow's still pretty long, but not quite as long as at 7 a.m. And it's still stretching out towards the west. So let's see what happens at 11 a.m. Well, look at that. The shadow's even shorter, but again, still pointing westward. So in the morning, it looks like the lamppost shadow starts out long and gets shorter as we get closer to noon. But they all extend to the west. What happens at noon? Hardly any shadow. The sun is high in the sky at noon, almost directly overhead. Depending on where on Earth an object is, its shadow will usually point north or south at noon rather than east or west. Let's see what happens to the shadow in the afternoon, jumping to 2 p.m. Looks like the shadows are getting a little bit longer again now that the sun's going lower in the sky. But unlike in the morning, the shadow is now pointing east. Will the shadow continue to get longer at 4 p.m.? Yep. It's definitely getting longer, still pointing east, too. How about 6 p.m.? The shadow's about as long as it was in the morning, right? But again, unlike in the morning, the shadow is stretching out towards the east. So what patterns did we see the lamppost shadow follow? Let's look at these two bar graphs that recorded our observations. In the first graph, we've charted the length of the lamppost shadows. Based on what we observed with the lamppost, the sun created long shadows in the morning when it was rising in the east. When it was almost directly overhead at noon, the shadows were shorter. Then, as the sun set in the west in the afternoon, the shadows got longer again. And what did we observe about the direction the shadows were going in at certain points of the day? Well, like the second graph shows us, we saw that the shadows in the morning and afternoon faced two different directions, and the midday shadow was somewhere in between. So graph number 1 shows us that when the sun is low in the sky, shadows are long. When it's high in the sky, shadows are short. Graph number 2 shows us that whatever direction the sun is in the sky, the shadows it creates will point in the opposite direction. So now you know what a shadow is, and that it changes in both length and direction during the day, depending on where the sun is in the sky. Basically, the sun is your shadow's boss. Yes, sun, no sun, whatever you say, son.
So we're going to stop that video here. Right here, I have a model. This model is what we're going to use to show how something works. Here I have a party horn. It works just fine here. All right, cool. So we have a party horn. You don't have to have a party horn. Actually, if you want to try this out at home, you can use like a flashlight or even a phone. So like you can use the light on a phone and we'll be able to see the shadow. So if you have any type of light, so I'm going to use a flashlight. You can use a flat light on someone's phone. You don't also have to have a party horn. You can use maybe like a water bottle and just put it in the middle, or you can use like a light saw bottle. You just put it in the middle. Anything that you can use to block the light. You'll be able to see like a little shadow with the water bottle because it's clear. It's transparent, like that word we talked about in light and sound. So I'm going to use this party horn here. I have my flashlight here. You can put your video on pause if you also want to try this model out. So we're going to show how the sun, so this is going to be my model of the sun, and this is going to be my model of a tree. This is my model of the sun. This is my model of the tree. We're going to be seeing how the sun moves in an arc-like way around the earth, or it appears to look like the sun is moving around the earth in an arc-like way using the sun and the tree. What you're going to do, you're going to turn. Okay, not that light. Didn't like that one. All right, cool. Here we go. So when the sun rises in the morning, we can see the shadow. Remember, so the shadow will be on the opposite side. This is the sun rising in the east, and it'll set on this side on the west. So when the sun rises in the morning, most of your shadow will be this way. So you can tell that it is morning based on if your shadow is on the west side, because that means that the sun is just rising on the east, which means my body is blocking things on the east, and the shadow will be on the west. As the sun goes across the day, or as time moves on, you see the shadow starts to move. It's because the sun is moving up and going higher, and it's turning different times around the day. So as the sun goes up, your shadow moves throughout the day, all the way until it sets. And when the sun is about to set, your shadow is now on the east side. So this our tree didn't move. The sun moved in an arc-like way around the tree, and this made the shadows move. So I'll start that over again. So we have the sun rise, and it goes in an arc-like way. It's like that rainbow type way, and then it sets. So I'll show you that again. The sun rises, goes all the way up, and then it goes all the way down to where it sets, and then we don't see the sun anymore. We also are going to watch a quick GIF here where we can see a better visual of what we just saw. So here we see the sun rising in the east, and then it goes all the way up, and then it sets in the west. This is what happens every day. It doesn't quite get all the way to set, but we can see how the sun is setting throughout the day. So the sun moves from east to west every day, and we're able to see the shadow move. Our shadows move all day because the sun is moving. So we're going to look at one more thing before we complete our exit ticket. So here, we're going to have three different models we're going to look at, and we're going to have to figure out which model is the best model to show how the sun moves across the sky. So we have model one here. Model one shows the sun moving horizontally, means it's going straight across. The sun's just moving straight across like an airplane, like that. But we know that if the sun moved like that, then the other side of the earth would not get sunlight. It's just moving straight across. And we know the sun rises and sets. Right here, the sun doesn't rise or set. So model one cannot be correct because it doesn't show the sun rising or setting. It just shows it goes straight across. Model two. Model two shows the sun moving in an arc-like way across the earth. This shows it moving from east to west. I'm going to keep that there because I don't know if that's right yet. It sounds about right, but I might want to look at model three. So model three shows the sun just going up. It's going in a vertical way, just going up. But we know this might show the sunrise, but what about sunset? The sun is not going to set if it just goes up because it'll never go down. And that'll be the problem. If it doesn't go down, then we'll never see sunset. We'll never see nighttime if the sun just goes up, 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 up. It'll never be sunset. So I know that model two is the best answer. It is the correct answer because it shows the sun going in an arc-like way across the earth. So it'll show sunrise when it comes up, and then it'll show sunset when it goes down. This is lesson 5 of our science unit. You guys have an exit ticket. You'll be able to use the answers or the things that we just learned to figure out your answer. See you guys next time. Mr. Jennings loves you guys. Bye.